Right. Assalamualaikum and a very good morning. So today we continue with trust, but specifically on method of section. Okay, let's say you have this kind of question. You have to determine the force in member GE, GC, and also BC. And you have to state if the members in tension or in compression. So what we should do first, that's the step procedure that I summarized for you so that it can help you to solve the problem. Okay, so the first thing, of course, we need to write the problem statement. The problem statement for this question, you need to find the member GE, the force in member GE, okay, GC, and also BC. So of course, right, so the first thing that we should do is we need to draw the FPD for the whole structure. So first thing, okay, we write it first. We have to draw the FPD for the whole structure. Okay, next, what should we do after we have drawn the FPD for the whole structure? Okay, so I have to move up all this part, right? So we can have a space to write. The next step, of course, after we draw the FPD for the whole structure, we need to find the support reaction. Okay, actually it depends. It depends on the situation. Sometimes we don't have to find the support reaction first. Okay, but right, for the beginner, it's best to find the support reaction. Okay, you have to find the support reaction. Okay, so in this case, we have a pin. The truss is supported by pin and also by roller. So we can see that the truss is supported by pin at A and supported with roller or by roller at point D. So we have to calculate that, right? So find the support reaction here. It means we have to calculate. So we calculate. Okay, I put it here. Calculate. So we don't confuse. Okay. The next step is we need to identify the zero force member. Okay. You can do step number 3 first, like after you draw the FPD for the whole structure. If you want to identify the zero force member first, it will be okay. Okay, or you want to follow after draw the FPD for the whole structure, you want to proceed with step number 2, find the support reaction or calculate the support reaction, also can. So step number 2 and number 3, it's either one. It's either you can put step number 3 to be number 1, or the other way around. Okay. So after the zero force members, I'm going to explain that in a different section. But actually, for those who attend the class, they know that how to find the zero force member. But for this time being, I'm going to show the basic one. So after we identified the zero force member, the next step is to, because we're going to use method of section, so we have to cut the selected member. We have to cut the selected member. Cut the selected member. Cut the selected member. In this case, you can see that the question clearly stated that we need to find the force in member GE, GC, and BC. So of course you have to cut member GE, member GC, and member BC. So we cut. After we cut, you can see that the truss is divided by 2 sections. So we can say this is the first section, and the other side it will be the second section. Okay, so it's up to you if you want to choose section 1 or section 2 to do the analysis. But the best is to pick section that have less number of force. Why we choose section that have less number of forces? Because we don't want to complicate our calculation. Okay, so once you have decided to select which of the section, then you need to draw. So I'm going to continue to this side. Oops. Okay, something. Okay, so I need to. Okay, okay. Right, so I need to okay, step number 5. Step number 5. We need to draw the FBD for selected section. Okay, so you can choose section 1 or section 2. The result you will get the same, but in order to help you to simplify the problem, try to choose section that have less number of forces. Okay, later I'm going to show you, but now we will go through for the whole step that normally we can do in order to solve this problem. Okay, for the truss problem using method of section. So step number 5, we draw the FBD for selected section, and then 6 for step number 6. Okay, when you draw the FBD for the selected section, so we solve the problem. Solve the problem using equations of equilibrium. So you can use fx, fy equal to 0 and moment equal to 0. For method of section, it's very important for you to understand completely on how to find the moment. If you have this problem in section in previous chapter, in chapter finding moment, then you will have a difficulty to solve this problem. So make sure that you understand completely on how to find moment. Okay, so after we have solved the problem using equations of equilibrium, so you can double check your answer. So you can use another section to verify your answer, or you can also different moment, different point to solve, to check your answer. Okay, so you can check your answer. Check your answer. Okay, so we have finished the step or the things that normally we have to do in order to solve the problem, to find the force using method of section. Okay, it's very important to draw the FPD, to find the zero force member, and also to make sure that you understand completely on finding moment. Okay, so after this, we will do the calculation. I'm going to show you the calculation step by step until 7. So now we are starting to calculate, but of course the first step to solve this problem is to draw the FPD for the whole structure. So we have to draw the FPD for the whole structure. Okay, FPD for the whole structure. Okay. Okay, so I have drawn the FPD for the whole structure, except that I did not put the support reaction. Okay, so as we know that at A we have a pin, so we put here we can put AX, right, and this one we can put AY, and for roller we know we have one reaction, so we put this one as a D. Okay, so you can put ND or D, it's up to you. So we have draw the FPD for the whole structure. So this is the FPD for the whole structure with the support reaction. So the next one we need to calculate. We need to calculate the support reaction, AX, the AY value, and also ND, the normal force at D for the roller. So in order for us to solve the problem, so the next step, we know that we have to calculate the support reaction. X, AY, and ND. Support reaction. Okay. So for AX, AY, and also D. So we use the equations of equilibrium to solve the problem. So we can use, in this case, we can use moment at A, right? So we can eliminate the AX and AY in the equation, so we can only have one unknown. So, right, we use summation moment at A, right? Counterclockwise is positive, so it's equal to 0. That we have here is 12 kilonewton. Okay, because we said that counterclockwise is positive and moment about point A, so we can see that 12 kilonewton is a clockwise, so it becomes negative, right? And then times with 6 meter. Okay, we have the normal force T. Okay, so because it will have counterclockwise, so you can see here that we only have two external force. If we choose point A to calculate the moment, so we only have 12 kilonewton and force at D. So we know that 12 kilonewton will rotate clockwise. Then normal force at D must be counterclockwise. So to make sure that it is equal to 0. So this one should be positive or plus because it's rotated counterclockwise. The force tends to rotate the body counterclockwise. Then we have this normal force T. Okay, and we have to multiply by 9 meters. So be careful, right? So don't do the careless mistake. So it is equal to 0. Okay, we try to solve that. So we get normal force at D is equal to 12 Newton times 6 meter divided by 9 meters. So you get the value. So we get the answer is 8 kilonewton for normal force D. Okay. After we have calculated the normal force for at D, we get 8 kilonewton and the force from the roller. Then we can calculate the support reaction at pin A, which is we can find AY and also AX. Actually, we can see here AX is equal to 0. Why AX equal to 0? Because there is no external force that you can see in the truss beside AX. So when you write the equation, the summations of Fx equal to 0. Okay. And because we only have AX, so we know that there's no other external forces here, and we get AX equal to 0. So AX is very easy. Then for the AY, to find the AY, you have an option. You can use by doing summations of Fy equal to 0, or you can also choose, if you love to do moment, then you can find AY by using moment at point D. So it's up to you to choose which one that you want to get the answer for AY, but both are correct. Okay, so if you use summation of Fy equal to 0, then you know that we have negative 12 kilonewton there, and from the force at roller, we know that this is positive 8 kilonewton and plus AY, so equal to 0. So AY equal to 12 kilonewton, okay, minus 8 kilonewton. So it means AY is only 4 kilonewton and it is in right direction. Okay, so if you have negative, if you get the AY negative, it means the sense should be reverse. Okay, so we will see through throughout this sample or this example. Okay, so right now, based on this FPD, based on this support reaction, and we know that for pin, we can we can assume that AY upward or AY downward. So when you get the, if those who choose to draw the FPD with the AY downward, you will get the negative value. So it means it is not correct. So you have to change, and the final answer should be here. Okay, right. Okay, so for AY 4 kilonewton. Now, if you consider to do or to double check your answer, you can also use moment at point D. So to get the AY moment at point D, we assume we know that the summation is equal to 0, and we assume that the counterclockwise is positive. So we have 12 kilonewton, and it tends to rotate counterclockwise, so it becomes positive. So 12 kilonewton, okay, and then you multiply with 3 meter the distance. Okay, then we have the AY. AX will not produce any moment, and at the same time we know that AX is equal to 0, so it's nothing there, so it's only AY. So we have AY, and AY should be negative. Okay, you can see because we only have two forces there in our calculation for moment at D. So one is positive, this one is 12 kilonewton counterclockwise. It means the other force should be clockwise and should be indicated by the negative sign. So this is the AY. Okay, and make sure that you take the direction, the length correctly. So we have the 6 meter, 9 meter there. Okay, so 9 meter here. So it's equal to 0. Okay, then you rearrange. You can get the AY. Okay, is equal to 12 kilonewton times 3 meter divided by 9 meter. Okay, so you also have the same, you can get the same answer, which is 4 kilonewton. Okay, 4 kilonewton. Alright, so I need to I need to put the answer, because we don't have space there. So we put here 4 kilonewton, and should be upward. The direction, it should be upward. Okay, so we have this one. So you can also check, double check your answer, or it can be your option to calculate the AY value. Okay, so you write the 4 kilonewton there, 8 kilonewton there. So we already proceed with this, we already in step 2. We can now move to the step 3. Step 3 is actually zero force member. We can also identify before we draw the FPD or before we calculate the support reaction. Okay. Okay, so we have done the step number 2. We can move to step number 3. Like I told you earlier that zero force member, you can also identify earlier. You can identify as a first step or second step. It's up to you, but it's very important to identify this zero force member in truss. Okay, so we have to identify the zero force member. So I'm going to use ZFM after this, yeah? ZFM. Okay, so based on this, you have to do the analysis. You have to identify the zero force member for each point. Okay. In detail, how to identify zero force member, it will be in my other video. So you can check that to identify easily the zero force member. So right now in here, we can identify the zero force member. Is there any zero force member here? So we look into point A. Okay, sorry, we have to refer. It will be easier if you refer your FB. Okay, because you can see that at the support reaction we have forces here. Okay, so from point A, no, there is no zero force member. Point B, we have here BG is a zero force member. So we identified that BG is a zero force member. Okay, BG is zero force member. Zero force member, I mean zero lah. Right, for this method, method of section, sometimes the zero force member does not involve in your calculation, right? Because you cut the selected member that not related with the zero force member. But it's very important if you are finding the force for each member of the truss. That will be the method of when you have to use the method of point. Okay, now we are we focusing on method of section. Okay, so sometimes zero force member here in a method of section is not influence our calculation because we do not cut to the or we do not cut that we do not cut member that are related to zero force member. Okay, so it's but as a beginner you have to identify, okay, whether it is used or not, that will be a different story, but for a beginner you should know about that. Okay, so now we have a zero force member here for BG. Is there any other zero force member? There is no for C because we have more than 3 member. We have external forces, so there is no. D also have external forces come from the roller. E, even though it's a 3 members at point E, but we don't have the collinear section. Again, if you don't understand the zero force member, you have to check my zero force member video, right, to specifically on that, so that it's very clear for you to understand about zero force member. Okay, G also does not accept this one, accept this member. Okay, so BG is a zero force member, but because the question asks you to find, you have to find the GE, GC and also BC. So you have oh wait, I have done the step number 4. Okay, alright, so I have to erase it first. Okay, so step number 4, you have to cut the selected member. So cut the selected member. Okay, this is a very easy to follow. Most of the time you only have to cut just one time. Okay, cut the selected member. So in this case we have GE, GC, BC, and with only one cut we can, we can get the the force for GE, GC and also BC. Okay, so we have cut the selected member, so we already cut, and we have a section 1 and section 2. Okay, So again, it's up to you to choose which section, but my suggestion is, oh sorry, I have to do that cutting in the, okay, right, in your FPD here. So you can see here that we have section 1 or section 2, it depends if you want to label as section A or section B, right? But we know that it become 2. But my suggestion is you have to select section that have less number of 4s. Okay, in this case you can see that section 1 only have 1 force. AX does not have any value. But if you consider section number 2, you have 12 kilonewton and also D. Okay, but remember, if you calculate incorrectly for AY, so it means after that your calculation is totally wrong. So be careful, right? Same like here, even though you have the 12 kilonewton, but if you did not calculate the D value correctly for the force at roller, 8 kilonewton here, then you also will have wrong answer. Okay, so you have to be careful, right? But again, if you want to select the selection, the best is to choose section that have less number of forces. So in this case, better to choose number 1. Okay, so we can choose number 1. So we have to draw, okay, we have to draw the FPD for the selected section. Draw the FPD for selected section. Yeah, section. Okay, so we decided to go for section number 1. We can also use section number 2 to double check your answer, but it's a lot of work. You can also still using section number 1, but you can use different point to double check your answer. But that one would be the last part in our session. Okay. Okay, we have decided to choose section 1 to do the analysis for GE, GC, and GB, right? So we know that here is point E, okay, and we know here, okay, we already cut that, right? I think this one we don't have to, oh, it's okay. This is the height. We know that this is 3 meter. 3 meter. And this is point C, and from here, okay, 3 meter. Okay, for your information, we don't put a 12 kilonewton because we cut this member and we choose section 1. Section 1, okay, you can see that 12 kilonewton is not part of section 1, it's a part of section 2. Okay, so we don't 12 kilonewton there. Okay, so just leave it as here, we have a 4 kilonewton, okay, GE, GC, and BC. Alright, and we know that we can, to solve this problem, we can do assumption that the tension should be positive. Or you can do inspection, but I know that it will be easier for us if we do assumption, right? Then if you already in another level, it means when you are expert, then then maybe that you need to do, maybe you have an option to do the inspection. Okay, so we have here, okay, we assume tension. So we assume tension. Okay, can remember? So tension, it should be away from the member because we are talking about the member. So tension, the force should be away from the member. It will be easier for you to remember that. Okay, so this is also away. Okay, now, right, we have draw the FPD for the selected section. We choose section 1. Okay, the next step is you have have to solve the problem using equation of equilibrium. So we solve the problem using equations of equilibrium. So number 6, solve using equation of equilibrium. Means that you can use moment equal to 0, f equal to 0, f equal to 0. Okay, so right. I did get it. You see here that for member BC, it's only have for x component. So because of member BC in x direction, and for member GE also in x direction. Then we know that the x here is 0, so if you don't put in your FBD, it is also okay, right? So you don't mix up. But again, you can see that BC and GE only have the x component, but not for the y. Member GC will have y component. So AY and GC, right, we can write in the equation of Fy equal to 0. So but before that, you need to know this one. Okay, we can do like this, or we can do like this. Okay, we can put it here so it'll be easier for us. So actually this one you don't have to put, it's also can, because we already put in here. Okay, so it would look like, you know, easier. Okay, so this one you can also so you can see clearly. Very nice. FBD, clear, clean. Okay, FBD. So we know that the height is 3, the width between the length between these 2 points, we have 3 meters. Okay, right. Okay, we have here square root 18. Okay, square root 18. Okay, so you can choose summation of Fy equal to 0. Okay, plus here, and then we have Ay. It's a 4 kilonewton positive. Okay, this one, because we assume first it is tension. So as you can see, okay, so we have negative, we have GC, negative GC. Okay, we have 3 over square root 18. And it is equal to 0. So as you can see that we only have 2 forces for y component. So the first one is from AY and the second one is from the y component of GC, member GC. So we have determined that the AY is, the direction is upward. So it means logically, of course, the GC, the component y for GC, it should be downward because we want to make it, it's in equilibrium. Okay, so it will be equal to 0. Okay, so you solve the problem. So we get 5.65 or 6 kilonewton. Okay, we get 5.66 kilonewton as for the GC, and the Fy should be downward. Yeah. Okay. So correct. Oh, we should see that whether it is in tension or in compress. So because it's positive, yeah, so our assumption is correct. So it is in tension because we get a positive. So we assume positive is tension. So our assumption is correct. Okay, so we already get the GC. Okay, so after we have calculated GC, now we have to make a decision. So what are the equation? What are the equation that we need to use after that? So we did not find BC and GC yet. So if you want to use fx equal to 0, you will have a problem. Why? Because BC and GE, you don't have the value. So it means in fx equal to 0, you have two unknowns. So it will not help you to get the answer. So in that case, you have to think for the moment, right? So moment, okay, let's say if you choose moment at point B. So if you choose moment at point B, you have a lot of things to put in your equation because you have to put the GC, you have to put the GE. GE is the one that we want to find, and also a Y in your equation. But if you choose to pick point G for your moment, you know that GE we don't have to calculate. GC also is not included in the calculation. So it's only left BC, one unknown, and also AY, the known force that we have calculated earlier. So the best is, for me, I think I should choose point G to get the value BC. So we write the moment, okay, at point G. Okay, moment at point G is equal to 0. Summation moment at G equal to 0, counterclockwise is positive. So what we have here, this one would not include in our calculation. GC, so it will be good because if you calculate wrongly for GC, it will not interrupt in your calculation BC. So that's why I think point D for this situation is better. It's a best choice for you to pick. Okay, so we put G right then. Now we start with AY clockwise. So because we assume counterclockwise is positive, so AY we put negative 4 kilonewton, right? So and then for the okay, don't forget that because we calculate the moment, don't forget to include the distance. This is the normal careless mistake that students always do. Okay, 4 kilonewton, clockwise it become negative, then we have B. Okay, so far we did not see that our assumption is not correct. So okay, but I think the last one we will see that. Okay, we continue with finding BC. So BC counterclockwise is positive. We have BC, right? Then point G, so it's also 3. There you go, you get the same thing. Is equal to 0. So you know that the BC is the correct one. Yeah, the sign is correct. The BC is equal to 4 kilonewton. So again, our assumption is correct. So BC is in tension because we assume that the positive, it is in tension. Normally we assume positive in tension, but if you want to assume compress is positive, it also can. But again, for the beginner, better for you to assume that the positive signs mean it is a tension. So if you get negative, it should be the other way around. So we get a BC. BC is a 4 kilonewton. What left? Okay, so the only left is GE. Okay, GE. So, right. So we put 4 kilonewton in tension for the BC. So BC is 4 kilonewton in tension. So I always put the information in the FPD so that it's very clear for me to find the answer, but make sure that your FPD is not too small for you to include all the information, because when it is too small, it's too crowded. So it's not helping you to get a clear picture. Alright, so we can find GE by using the summation of Fx equal to 0. Okay, we have BC. It's a 4 kilonewton in tension, so it will be positive. Okay, then for GE, right, we assume it's tension, so we put positive GE. Okay, another careless mistake that students always do, that you tend to forget that GC also contribute the X component in the equation. So you have to put the X component for GC. So we know that this is also in tension, so it will be pass. Okay, so 5.66 kilonewton. Then we have 3 over square root 18. So it's equal to 0. And you can see here something wrong with the equation here, because we want to make sure that it is in equal to 0. It is in equilibrium, but yet we have here positive, positive, and positive. So it means GE shouldn't be in tension. It should be in compression. Okay, so we can solve this one and get the answer. And because we have negative value, it means our assumption is not correct. So GE is supposedly to be in compression. So it will be in compress. So GE should be in compress. So this one, GE, it should be in compress. So you can write that is 8 kilonewton. Okay. Compress. Or you can also write like this as a reminder for you. This is negative. Okay, this is negative. So why I put this one? Because when we want to use that particular value GE, if you want to check double check your answer, or if you want to use GE for another calculation, so you should aware that the negative here, it means the indicator of the arrow is not correct. It should be the other way around. Okay, so we try to double check our answer. If we can get 0, it means what we have done here, it is correct. Okay, you can double check your answer. You can use moment at point B and you put all the information that you have previously. So you check whether you get 0 or not. If you get 0, it means what do you get earlier? It is a correct one. Okay, so as you can see, I already write the equation. So for moment at B, we can see that the 4 kilonewton, because it turned to rotate the body clockwise, so that's why I put negative, and we multiply with the distance 3 meter. Okay, and then for GE, right, this one you have to be careful, but at first you can write in general based on the FPD based on the sense that we put in the FPD. Okay, so we have the GE, right, tend to rotate. In here we see that tend to rotate clockwise, so I put negative first, times with 3 meter. And then the GC also, we don't have the Y component because it will pass through point B, so it will not produce moment, so only X, so we put X component, so GC 3 over square root 18 times with the distance 3 meter. Okay, so you put all the information, but for GE, because we calculate earlier that GE is supposedly to be compressed, so in our calculation, it will be easier if you just maintain the FPD, but you put the indicator negative here to show that our assumption is not correct earlier. So we just put here negative and then it becomes positive here. So this is negative 12, this is positive 24, and this is negative 12. So at the end, you will get the result is equal to 0. So it is proven correct. So verify. So we have finished on how to do the analysis for truss using method of section. It's very easy with the condition that you need to understand completely about how to find moment about a point. It's very important. If you don't pay attention on that side, you will have a problem in here, and you can always double check back your answer. Okay, this is one way to double check your answer, or you can also choose section 2, but section 2 to double check your answer, but it takes time. So this is the best way. So thank you very much. See you again. Assalamualaikum.